And we've got our full set of notes which you got this morning about the vector calculus. We will refer to them occasionally just to see what they look like and how good they are. And you know, there's some examples in there about converting parametric equations into Cartesian equations, which is what we're really going to sort of look at as part of what we're doing this morning. This afternoon. So, okay, and there's some nice examples that are there. So we're going to start with question number 53 in our question bank. That is there. Before we start, any questions? Now, just as always, as we've found out, there are too many questions in these to complete them all. So I've gone through and selected a few to have a look at. If we get time to do some more, but I don't think so because there's so much to cover, we'll go back and do some. Or if you think that a question is too easy or we don't need to do any more of that topic, let me know and then we can get on with some other things. Okay, so that's the idea of today. So, question 53. The position vector of a particle at time t is given by our rule, which is here. And we know, of course, t is greater than or equal to 0. Find the values of t for which the particle is closest to the origin and hence, so two parts to it. So find when the particle is closest and then hence find the closest distance of the two things we've got to find to the origin and the position. So three things we've got to find in this question. So maybe in VCAA they'll have A part 1, A part 2, A part 3 so you don't miss something. This is what they've normally done. So the distance, how do I work out the distance? How do I work out distance? Magnitude, someone said, I believe. That is correct. Okay, so we want the magnitude of RT, which will be the square root of our square root of 4t plus 1 all squared, and then we've got plus our 2t minus 5 all squared. Okay, we all good with that? Now, I'll just put something to you. Are you happy if I try to simplify some of these processes, because we know we can all expand out quite easily so we can get down to explaining more of it than just doing all the little algebra writing? Are we all happy with that? For some cases, yes or no? Yes? Okay. So we expand that out. That's not too hard. It's just the quadratic in a few terms. And we will get the square root of 4t squared minus 16t and plus 26. Okay. All right. Now, what do we have to do? We could actually call that R, couldn't we, perhaps? All right, we've got to find the closest particle is closest to the origin. So what do you suggest we do with that? Closest would be? Closest, you might like to put words. It's the minimum distance, isn't it? So how do we normally find minimums? Sorry? Take the what? Derivative. Come on, nice loud voice. Take the derivative. Okay, do you like square root functions? No. So what I'm going to do is, rather than that, I'm going to look at R squared. And I'm going to take the derivative of R squared, which looks pretty easy, doesn't it? Is 8t minus 16. And when we want to find the minimum, what do? Let it equal 0. Let's just put the R squared in brackets so we're quite clear on that. So we get our 8t minus 16 equals 0, and therefore we get t equals 2. Now, did you know that we could just take the derivative of R squared and let it equal 0? To save all that square root stuff and doing that? Who knew that? Okay, only one person perhaps. So that saved a lot of time, didn't it? Okay, so we have to work out the distance. So we're going to put t equals 2. So we're going to put t equals 2 in our rule of R. So R would be the square root of, and if we work that out, we would get, what do you reckon? 16 minus 32 plus 26, which we hope is root 10. Now, we have no units, correct? So should we write units or just leave it as root 10? Or should we make it quite clear as the closest distance? Maybe underline it, make it clear. Okay. We all happy with that? So T2. So we might say, you know, closest distance when T equals 2. We don't have units, so we'll just put time equals. What was the last thing we had to find? Find the position when it occurs. So we now have to work out R of the vector R of T, and if we substitute that in, and we'll just say we know how to do that quite easily, and we will get 3i plus j. And I should just put a 2 in there. So we're substituting 2 in R of T, so just make sure we put the 2 in there. And we will get 3i plus j. Now, should we make so what was it we had to do? Work out the last part? Position. That's the vector, isn't it? Do I have to put it in coordinate form? Yes, no? He reckons? No? No idea? Well, that's sort of it. Didn't ask for coordinates. So we could say, well, really, or we could say it's at 3, 1, couldn't we? Yeah? So, and we could say is the position. It's always good to make sure that we highlight where the answer is. Okay? So, and that's the closest part. Alright, we all happy with that? Now, your answers would do that. There's no quicker way of doing that that I can think of, and your answers roughly do about the same. So just like yesterday, if I do have a slightly different method, I'll let you know about that, which is a bit different to what's there. So we've already learned something for most of us, that if the derivative of r squared there, to find the minimum, was the same as taking the square root of that. So much quicker to do. Try it out at home the long way, and you'll see that when you let it equal 0, a lot of that stuff will cancel out. Okay, and we'll square both sides at some stage and we'll get the same equation that we solve eventually. Right, the next part, we are to find the Cartesian equation and sketch the path of this particle. Okay, so we had, so I just have to scroll back up there, since the equation's not on that page. So we're going to let x equal this part, and we're going to let y equals this part. Is that correct? Yep. So we're going to have x equals the square root of 4t plus 1. And we're going to have y equals minus, and we had 2t minus 5. Okay. What is the easiest way to get x in terms of y, or y in terms of x? Well, we really want y in terms of x. So we want y in terms of x. What's the easiest way to do that? T in terms of x. So the easiest one would probably be the first one. So we could say that x squared equals 4t plus 1. And then we could say that x squared minus 1 over 4 equals t. And then we're going to substitute that into the equation of y. So we're now going to substitute this. So just put a line there. We're going to substitute sub into y. And we're going to get y equals, maybe I'll expand that out first and sort of say it's minus 2t plus 5. And then we're going to get minus 2, excuse me, x squared minus 1 on 4 plus 5. And we will have that will be, don't know what you want to do with that, x squared minus 1 on 2 plus 5. And then we're going to have to put it all together. And we will find that we will have x squared, that's plus 10. So x squared minus 9 on 2. Look about right? Is that right there? No, it's not quite right because I didn't put my minus in there. So it'll be minus there. So we're going to have a minus x squared plus 1. So that will now be plus 11. And there's a minus x squared there. Alright, so let's just fix that one up. Now, when you're doing your exam, you have to pace yourself, don't you? And you might want to write it like that, up to you. Okay, you've got to pace yourself. So couple of things. Don't want to go too fast. What happens if you go too fast? Have mistakes. Okay? So you've got to pace yourself, which means between now and the exam, which isn't that long really, is it? You're going to have to do some practice and pace yourself. Now, we've got to sketch the path of that. So what do you suggest we do? What do you suggest we do with that? Sketch the path. Yeah, we just sketch that. All right, let's sketch the parabola. Okay. Yep, sketch the parabola. And how would you like that to be sketched? Why? Okay, who wants to sketch it? What's that parabola look like anyway? Okay, just a negative parabola. Okay, so the idea was, let's sketch that parabola. So we'll just go off and sketch that parabola. So the y-intercept will be 11 on 2, is that correct? And then it's going to come down and look like that, is that correct? Okay, is that the answer? Why not? Sorry, what? Intercepts. Okay, let's ignore the intercepts at the moment. Is that the graph? Yes? Right, the domain. We have to have t is greater than 0. Thank you for that. T is greater than or equal to 0, correct? Okay, so when we go back and look at our x values, so x was square root of 4t plus 1. If t is greater than or equal to 0, we are going to get that x has to be greater than or equal to 1. Okay, so this is 0, so it's going to start at 1. Okay, we happy with that? Okay. Now, if t is greater than or equal to 0, when we look at our y equation, and I'm just going to expand that out, minus 2t plus 5, it's going to be start when t is 0 at 5. So we know this will be 1, 5. Okay. Now, we're going to be subtracting values, aren't we? So when t was 1, we're going to be subtracting from 5, aren't we? T is 2, we're going to be so this will be that y is less than or equal to 5. Are we happy with that? So just when you come to look at the answer, it sort of looks like the turning point is at 1, 5, but it's not quite. It could be interpreted that, it is not. So we just have to fix this up a little bit, don't we? So I'm just going to go over this, because I know what's going to happen when I remove that line that we have there. Okay, oh, took the whole lot, didn't it? So we're only going to get our graph that looks that part. And when we work out the x-intercept, that's going to be root 11. And there's our graph. Okay, we happy with that? Okay, please don't forget the domain. So go to your two parametric equations. The x will give you the x values, the y parametric will give you the y values. Just substitute in, look what 0 is, etc. Alright, we happy with that? Any questions? Nope. All good. Okay. Just give you a moment, make sure we all got that down.